All right, we're picking up second video for chapter 4, section 2. We're adding, subtracting, and multiplying polynomials. We just talked about adding, subtracting. You can do it in both kinds, either vertical or horizontal. I don't care which way you do it, whatever your favorite is. Same thing with multiplying, whatever your favorite is. You just have to get it done. So now we're going to get into some more, complex multiplying. It's complex because you have to memorize a pattern. But if you memorize the patterns, it actually makes it less complex. It makes it easier to do. You can just follow the pattern. So, some binomial products occur so frequently that it is worth memorizing their patterns. You can verify these polynomial identities by multiplying. We're just going to talk about them. I'll show you a proof, and then we're just going to put them into practice. Okay? So, one of them is called sum and difference. If you multiply a sum times a difference, the sum of two things times the difference of those two things, you get a squared minus b squared. We know this is the difference of squares pattern. We did it in reverse back with quadratics. Something squared minus something squared factors into that the square root plus the square root times the square root minus the square root. Well, if you reverse that, you get something plus something times something minus something. You get something squared minus something else squared. For example, x plus 3 times x minus 3. You get the x's are squared, you're going to difference, and 3's are squared, 9. The square of a binomial, we know this one. This is a perfect square trinomial quadratic. Something squared plus 2 times the square roots times each other plus the last thing squared. We reversed it. So if we have y plus 4 squared, or y plus 4 times y plus 4, the first thing is squared, so we square the y, we get y squared. We take them times each other, y times 4 is 4y, times 2 is 8y, and then we square the last thing. 4 squared is 16. Works even if it's in a different order, or you have a number in front of the variable. 2t squared, 2 squared is 4, t squared is t squared, so 4t squared. 2t times negative 5 is negative 10, times 2 is negative 20, negative 20t. Negative 5 squared is 25 at the back. The one we don't know about yet is the cube of a binomial. If you cube a binomial, so you take that thing and you multiply it times itself 3 times, it's the first thing cubed plus 3, which is the exponent you have, times a squared b plus 3 times a b squared plus b to the third. Here's how I remember that. All of the exponents of the variables have to add up to 3. So we've got a to the third, that adds up to 3. We've got a squared and b to the first, 2 and 1 makes 3. The first thing is the higher exponent, and then it counts down. So it's a to the third, a squared, a to the first, no a. It's no b, and that one counts up. No b, b to the first, b squared, b to the third, and a to the first and b squared makes 3, and b to the third makes 3. They all have a total exponent value, a degree of 3. It's a times 1 on the front, and it's a times 3 on the inside. So in the example, we got z plus 3 to the third. So z is the first thing. We go to the third. And then we do 3 times z squared times 3. So that's 3 times z squared times 3. 3 times 3 is 9, z squared. That's where that comes from. And then we do 3 times z times 3 squared, which is 9. 3 times 9 is 27, z. And then we finally do 3 cubed, which is 27. It's way easier to write it down. You just write all the places, fill in the blanks. Okay, that's easy to do, just like that. So let's look at the proof. So proving a polynomial identity, we're not going to do this in our, well, you're going to kind of do it, but prove that the polynomial identity for the cube of a binomial representing a sum a plus b to the third. They show you all that stuff, use it to calculate, and then bam, here we go. So if we do ab times times, or a plus b times a plus b times a plus b. The first one becomes a squared plus 2ab plus b squared times ab. And then it's a times all of that plus b times all of that. So you get a to the third, a squared b plus 2a squared b, 2ab squared, ab squared plus b to the third. Add your like terms. Checks out all right. Okay. So you can actually calculate the cube of a number by turning it into a binomial. That is of numbers that are easy to cube. So 11 cubed is kind of weird, but cubing 10 and cubing 1 isn't so hard. So if we turn it into 10 plus 1 to the third, so that's 10 to the third plus 3 times 10 squared times 1 plus 3 times 10 times 1 squared plus 1 cubed. 1,000 plus 300 plus 30 plus 1. 1331. We'll probably skip those problems in our homework, but it's a way that you can use to do that. Most of us will probably just pull the computer out of our pocket and use the calculator. All right, find each product. Notice that it's the same start, same back, but they're a difference. So it's going to be that pattern. Let's go back and look. It's going to be the first thing squared minus the second thing squared. So it's going to be 4n squared minus 5 squared. 4 squared is 16. N squared is n squared. 5 squared is 25. This one we're doing a binomial times itself. Let's go back and look at the pattern. Binomial times itself. The one with a minus in between, right? Yep, minus in between. So it's going to be this guy right here is what we're looking at. So we're going to square the first thing. We're going to multiply each times each other and double it. And then we're going to square the last thing. So we got 9y squared minus 2 times 9y times negative 2, or times 2, not negative 2. And then we've got, double check the pattern, plus b squared plus 2 squared. If you want to, do it fill in the blank. First thing squared minus 2 times first times second plus last thing squared. If it's minus in between, it's minus in the middle. If it's plus in between, it's plus in the middle. The back's always plus. And then just fill in the blanks. 9 squared is 81, y squared. Let's see, 2 times 9 is 18, times 2 is 36y, and 2 squared is 4. Now we've got C. I'll do that in a different color down here. Okay, let's look at the pattern. First thing cubed plus 3 times thing squared, thing single. Okay. Oop, I went to the wrong one. There we go. And we're in the plus in between. Okay, and there's a pattern to that even that you can memorize. If it's plus, they're all plus. If it's minus, it's plus, minus, plus, minus. It's every other. Okay, so we're all pluses. So it's the first thing cubed plus 3 times the first thing squared, next thing, plus 3 times first thing times next thing squared, plus second thing cubed. They all have to up to 3. So then we just plug in what's in there. This is an AB. This is an AB. That's a 4. This is an AB. That's a 4. This is a 4. AB to the third means A to the third, B to the third. 3ab squared to the 4. 3 times 4 is 12. AB squared. A squared, B squared. Because the 2 goes to both. Just like the 3 went to both. Exponent property. 4 squared is 16. 3 times 16, let's see, 30 plus 18 is 48, AB. And I've done this one and that one and that one. And 4 to the third, so that's 16 times 4. 4, 20, 64. And it's in descending order. A to the third, B to the third. The degree is 6. A squared, B squared. The degree is 4. AB, the degree is 2. There is no degree on 64. The degree is 0. Okay. Find the product. This uses something from the last video, and then it incorporates that pattern thing. Refer back to that pattern page there in your book. That's why that's there, until you get it memorized. And then just start working on memorizing the pattern. A binomial, positive times a negative, going to be difference. They're different signs, so it's difference in between. Square it, square it. If it's the same thing squared, if it's plus, they're all plus. If it's minus, it's minus plus. Square it, multiply together times 2, square the last. Cube, 1 times something cubed, plus 3 times something squared something, plus 3 times something something squared, plus something cubed. Plug it in. Find the pattern. The plus is plus plus plus. The minus is plus minus plus minus. Give them all a try and come back. All right, let's try it. Number 3. 4x squared plus x minus 5 times 2x plus 1. Just distribute. Everybody times everybody. 4x squared times 2x. 4 times 2 is 8. X squared times x is x to the third. Plus 4x squared. X times 2x is 2x squared. X times 1, x. Negative 5 times 2x is negative 10x. Negative 5 times 1 is negative 5. 3, 2, 2, 1, 1. So 8x to the third. 4 and 2 makes 6x squared. X and negative 9x. Negative 5. Let's do number 4. Y minus 2. 5y squared plus 3y minus 1. Y times 5y squared is 5y cubed. Y times 3y is plus 3y squared. Y times negative 1 is negative y. Negative 2 times 5y squared is negative 10y squared. Negative 2 times 3y is negative 6y. Negative 2 times negative 1 is positive 2. 3, 2, 1, 2, 1, none. 5y cubed stays. 3y squared negative 10y squared is negative 7y squared. Negative y and negative 6y is negative 7y. Like sign, going to combine. Plus 2. Number 5, we got to do 3 of them together. So do 2 at a time. Use these 2. So m minus 2 times m minus 1. M times m is m squared. Negative m. Negative 2m. Positive 2. M squared minus 3m. Like sign, going to combine. Plus 2. Did those. Now we got to do times that last piece. M plus 3. Don't forget all your pieces. M squared times m cubed. 3m squared. Negative 3m squared. Negative 9m. 2m. 6. They're all next to each other. M cubed. That goes to 0. Negative 9 is negative 7m. And 6. They're doing them just like the examples that we went through. Those first 3 were from the last video. These next 4 will be from this video. So, number 6. 3t, 3t, 2, 2, 1's plus, 1's minus. That's a difference. So on number 6, I know all I have to do is the first thing squared minus the last thing squared. First thing's 3t, last thing's a 2. 9t squared minus 4. Just follow the pattern. It helps to memorize it. You go faster. 7, it's the same thing times itself. The way that goes is you got something squared plus 2 times something plus something squared. 5a is the first thing. 5a goes in the first. 2 goes in the backs. 5a squared is 25a squared. 2 times 5a is 10a times 2 is 20a. 2 squared is 4. And it's a perfect square trinomial. Squared at the front, squared at the back, plus sign in the middle. Square root of both times each other doubled makes 20. 5 times 2 is 10. 10 times 2 is 20. Number 8. That's the cube pattern. Something cubed plus 3 times something squared times something plus 3 times something squared plus something cubed. The front thing's xy. The back thing's a 3. Now, what I didn't remember, and I'll do it in a different color to show you, is this one's plus, this one's minus, this one's plus, this one's minus. Plus, minus, plus, minus. Gotta watch that, okay? The other thing you can do to not have to watch that is just make them all plus, but whenever you pull that number out of the parenthesis, you just take the sign with it, okay? Instead of putting in 3 here, I'd put it -3, and then you don't have to remember the pattern at all. That's kind of a good way to do it. X cubed, y cubed. Got it. 3 times 3 is 9. Distribute that in, x squared, y squared. 3 squared is a 9. 9 times 3 is 27, xy. Got that, got that. 3 cubed is 27. Boom. Last but not least, number 9. It's got a couple of parts. 1, prove the polynomial identity for the cube of a binomial representing a difference. Okay, we just have to do the math. And then use the cube of a binomial in part A to calculate 9 to the third. All right, well, we can do that. Let's think about that. So we do, whoa, weird button. Doing a minus b times a minus b times a minus b. They did the plus, but they're making us do the minus. So a times a is a squared. A times negative b is negative ab. Negative b times a is negative ab. And then positive b squared. So a squared minus 2ab plus b squared. And don't forget, it's all times minus ab. Got to bring that down. A squared times a is a to the third. A squared times negative b, negative a. That's supposed to be an a, not 2. Negative a squared b. Negative 2ab times a is negative 2a squared b. Negative 2ab times negative b is positive 2ab squared. B squared times a is ab squared. And b squared times negative b is negative b to the third. Let's see, what are like each other? Any more a to the thirds? Nope, it stays. A squared b's. These are like each other, a squared b's. So I got negative 3 a squared b's. AB squareds, I got AB squareds right there. So 3AB squareds, negative b to the third. That's the pattern. So then we use it to calculate 9 to the third. Okay, we'll do this one. All right, what numbers can we use to make 9 that are easy to square? I don't know. You could do 4 and 5. You could do 1 and 8. 8 gets pretty big. What about 4 and 5? So if we do something cubed minus 3 times something squared something plus 3 times something squared minus something cubed. And we did 9 as 4 plus 5. Actually, it's got to be a difference, doesn't it? So how can we do a difference? Ooh, we could do 10 minus 1. That's how we could do it as a difference. So this one gets a 10. That gets a 1. 10 to the third. 10 to any exponent is just that many of zeros. So 1 with 3 zeros. 10 squared is 100 times 3 is minus 300. So we did that one and that one. 1 squared is 1, so that doesn't matter. That's just a 1. So 3 times 10 is 30. And we're going to minus 1. Well, 1,000 minus 300 is 700. Plus 30 minus 1 is 29. So that's 729. Do it that way. It's easy to read for the calculator. That's what I would do. Now, as we look at something to the third, there is actually a progression for a binomial that is adding, okay? Has to be adding a plus b. Highlight that right there, a plus b. They have to be adding. As long as they're adding to any exponent, there is a pattern that you can use like we did with the squared stuff. And it's called Pascal's triangle. This guy Pascal, French mathematician, discovered this back in the 1600s. Okay? So if you follow the triangle, and the way you create the triangle, the first and last numbers in each row are 1. Every number other than 1 is the sum of the closest two numbers in the row directly above it. The numbers in Pascal's triangle are the same numbers that are the coefficients of the binomial expansions. And the exponent part follows that descending and then ascending rule. So if we look at the Pascal's pattern, it has to start and end with 1. So the first level, b to the or anything to the 0 is a 1. And then the next level, it starts in 1 and ends in 1. Okay? And then the next level, it starts in 1 and ends in 1, and the stuff in the middle is the result of the next closest to it. So 1 plus 1 makes 2. The next level starts in 1 and ends in 1. And the closest things to the 3 are the 1 and 2 and the 1 and 2. Those make 3. And the 1 and 3 and the 3 and 3 and the 1 and 3. And the 1 and 4 and the 4 and 6 and the 6 and 4 and the 1 and 4. And that's how you get the middles of each next progressive line. So if we did the next one, it'd be 1 and 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. Didn't want that little line there. 1 plus 5 is 6. And that's what it would be if it is to the 6th. And then to the 7th. And to the 8th. And da-da-da-da-da. So you can actually do any binomial sum to an exponent. All you have to do is create Pascal's triangle and you know all the coefficients. Now the exponent parts is the first one, the one with the 1, has got the full number of exponents. And it's the first term. And the next one is one less exponent and one of the next one. And then one less exponent and another one of the next one. And one less and more. And one less and more. And none and full of the last. So let's try Pascal's triangle to expand these. And you can actually do it with a negative, looks like it shows there. Okay, so if you're going to do it with a minus in there, take the sign with the number. So we're going to do it to the 5th. I'm going to cheat and just look back at Pascal's triangle. It's 1, 5, 10, 10, 5, 1. So it's 1 times something to the 5th plus 5 times something to the 4th times something to the 1st plus 10 times something to the 3rd times something squared plus 10 times something squared times something to the 3rd plus 5 times something to the 4th plus something to the 5th. X goes in the first ones till you run out, and then negative 2 goes in all the rest. And you don't have to worry about a pattern of plus signs. You just take the whole thing with you. So that's x to the 5th. Negative 2 to the 1st is negative 2, so negative 10x to the 4th. Negative 2 squared is a 4. 4 times 10 is 40, x to the 3rd. Negative 2 to the 3rd is negative 2, and negative 2 is positive 4 times negative 2 is negative 8. So that's negative 80x squared. Negative 2 to the 4th, well, negative 8 times a negative 2 is going to be positive 16. That's a 16. 16 times 5, 50, and 30 makes 80x. And negative 2 to the 5th So 16 times negative 2 is going to be negative 32. And we expand it all the way. If we do b, I'll do it in a different color. It's to the third, so it's a 1, 3, 3, 1. So something cubed plus 3 times something squared times something plus 3 times something squared plus something cubed. 3y goes in the front. 1 goes in the back. So that's 27y cubed. It goes to the 3 and the y. Did that one. It goes to the 3 and the y, so that becomes 9y squared. 9 times 3 is 27y squared. Don't have to worry about times 1. 3 times 3 is 9y, because 1 squared is 1, and 1 cubed is 1. Goes just like that. Last couple for you to try. Go ahead, give it a pause. Find the pattern, go back to the Pascal triangle page on your book, use the pattern, create the parentheses, fill in the blanks, do the math, and come back and find the answer. All right, let's do A. Start with green. It's to the fourth. Let's go back and look at 4. Level 4, 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Something to the fourth plus 4 times something to the third, something to the first plus 6 times something to the second, something to the second plus 4 times something to the third plus something to the fourth. Z goes in all the fronts. 3 goes in all the backs. 3 to the first is just 3. 3 squared is a 9. Doing my exponents first. 3 to the third is 27, and 27 times 3 is 1, 26, 7, 8, that becomes 81, okay. So z to the fourth plus 12z cubed, gotcha. 9 times 6 is 54z squared. 27 times 4 is 8, 2, 4, 5, 6, 7, 8, 68, z plus 81. Oh yeah, B for blue. That one's a to the fifth-er. Go back at the Pascal's triangle, look at it. 1, 5, 10, 10, 5, 1. So something to the fifth plus 5 times something plus 10 times something plus 10 times something plus 5 something plus something. Let's say this would be 4, 1, be 3, 2, 2, 3, 1, 4, fifth. What are we plugging in? 2t. And a -1. Take the sign with it. You don't have to worry about what signs you put anywhere. Now negatives make a difference, especially on the odds. So make sure you settle those right. So I'm going to do my exponents. 2 to the fifth is 32t to the fifth, goes to both. 2 to the fourth, that's 16t to the fourth, times 5. 5 times 10 is 50, plus 5 times 6 is 30. That makes 80 t to the fourth times -1. I should have done that better. Let's do that again. Don't forget them all, right? So it's going to be times the -1 makes it minus 80 t to the fourth, okay? 2 cubed is 8t cubed, and -1 squared is a +1, so we don't have to worry about that. So it's just 80t cubed, 10 times 8. And then we've got 4t squared and -1, so that becomes a negative, and 40t squared. And we got -1 to the fourth is a +1, so we don't have to worry about that one. 5 times 2 is 10t, and -1 times an odd is going to be a -1, and bam-a-lam. That's a good one and a big one. That's adding, subtracting, multiplying, and dividing polynomials. Memorize those patterns. It makes it way easier to do. These are not typable in the graphing calculator. You have to just do the math. Now you can use it for all the little pieces, the numbers to the exponents, and multiplying the numbers together and adding the like terms, but you can't just type it in with the letters in the calculator and get it done. You got to do the math.